Hey everyone, this is Derek, and this is going to be a short little video on properties of logarithms. This is for the business calc class, so we're going to focus primarily on natural logs. And then that said, I'm going to do a couple of examples of just kind of really simple ones to run through these properties, and then I'll show you again how they would look on the homework. And for these simple ones, I'm just going to use kind of plain old logs. So if I had log of, it doesn't matter, 7x, we have this property here that says if I have a log of two things multiplying, I can rewrite that as an addition. So I could say log 7 plus log x, and we'll work the exact same thing as ln's. Number 2, this one says if I have something like log of, 9 over x, I can write that as log 9 and then minus log x. So when I have multiplication, it becomes the addition of two logs. When I have division, it's a subtraction of two logs. It's the same rules as our exponents, it's just with logs. Third one goes, if I have something raised to a power in a log, so say I have log x to the 12th, I can bring the power down front. So I can rewrite that as 12 log x. And so that's kind of our three basic properties. And then what we do is we put those all together and we use that to rewrite logarithms. And sometimes you're going to find that we're going to want an expanded form like this. Sometimes you're going to find we're going to want it written as a single log. It depends what we're trying to do with it. If we're going to integrate it, we're going to really like this a whole bunch. If we're trying to solve an equation, we're going to like that. So it just sort of depends on what our goals are. Let me do one more example. And so this is the example I do when I'm teaching like business or regular pre-calc, just to try to kind of show that these three rules, you can think of them all together at once and not do a bunch of steps on these. So say I have this, make that a 4d5. So anything that comes out of the numerator ends up addition. Anything that comes out of the denominator ends up subtraction. So the a and the b, those are both going to have positive coefficients because they started in the numerator. Anything that comes out of the denominator, negative coefficient. And the reason for that is this. I can rewrite this as that if I do negative exponents. And so then you can see these, when they come down front using this property, they're always going to have that negative. And so then, since I have four things, this is long, this will be longer than most of what you'll see on the homework, but these exponents always become the coefficients of the logs every time. So like here, the 12 comes in front, we'll have a 2 in front of the a, a 3 in front of the log with the b, and so forth. So this is going to be 2 log a, and then 3, and it'll be positive because it's from the numerator, log b, and then this is out of the denominator, so I'll be a minus 4 log c. This is also in the denominator. I know they're multiplying and people want to put a plus there, but think of what the exponents would do if you bring them up. They're both negative, so that's minus 5 log d. So that is an easy way to think of those three properties together rather than kind of three distinct things. So let me show you what they'll look like on the homework. So the directions on the homework vary a little bit. So there's one version that says use the properties of natural logs to expand each logarithmic expression. Round answers to 3 decimal places if necessary. So some of them are going to want you to, when you have like a natural log of a number, they're going to want you to take that, just put it in a calculator, make it 3 decimals, and then that's it. Other questions where they don't have that in the direction, we just want you to leave like ln7. They wouldn't want you to change it to a decimal. So just be a little bit careful to read directions and you'll know which ones are which. So to do this, we kind of have, this is sort of that log of the top over log of the bottom, right? So if I was just going to do it in maybe do a step, I could think of this as this. And that's using property 2 from this last page, right here. But then notice I do have 2 things multiplying, so really I still need to break this up as well. And so I'll make this natural log of 5, and then these are both from the numerators, they'd be plus. You don't have to show this step, I'm just kind of showing a step there. And then, so depending on the directions, that would be it. Or for this particular problem, since it says round answers to 3 decimal places, ln5 is just a number. And if you put that in a calculator, you should get 1.609. And then that would be your final. Notice here I'm not trying to break this up because this is x minus 9. It's not, we don't have anything in our properties about addition or subtraction happening, right? Only multiplication, division. So this just kind of acts as one unit. That next one, so this 1200 is going to end up multiplying everything. And I checked the form of the answer on the computer and they don't distribute it. So I'm just going to leave that out front and think of it as kind of this times ln x to the 5th plus ln y. And then that 5, that's our property 3, right? That's where we have this exponent, so we bring that in front. And then that's how they left it on the computer. So that is how I would type it. You could also distribute. Factored can be nice depending on what you're about to do with it though. So question 6 is actually going the opposite way. So now we're going to use the properties to rewrite the expression as a single log. So we're kind of being given this piece. We're trying to get back to here. So if we're going to write something as a single log, it's always good to start off by writing down a single log. So we don't want log, log, log all over our answer. We're going to have an x and it's going to have a power of 4 because remember the numbers in front were exponents. It's going to be in the numerator because that 4 is positive. We're going to have a y to the 5th, and that will be in the denominator because the 5 is negative. We're going to have a z squared because the negative in the denominator. Here, these are adding, so that means they would multiply. And then I think in the computer they did multiply those out and got ln x squared minus 4 was the version they preferred.